Welcome to another podcast. In this episode, we're going to be taking a look at another improper integral. This time it's going to be improper integrals of type 2. And one of the things that you should note for an improper integral of type 2 is different than type 1 where the actual interval is infinite. Type 2, the function that you're integrating has an infinite discontinuity somewhere on the interval. So for example, if you take a look at this particular problem, you can see that when x is 1, the function 1 over 1 minus x has an infinite discontinuity. Basically, we have to be really careful when we get close to that value. So here is this infinite discontinuity. We would call it a vertical asymptote. So it's a vertical asymptote. Back in pre-calculus or even Cal 1, you would have talked about these. And the idea for type 2 integrals is very similar to the idea for type 1. You basically start as far away from the infinite discontinuity you can, which in this case is at 0, and you sort of look at a definite integral up to a certain value. So this is the definite integral up to the value n. And so we calculate the area based on n, and what we allow to happen is we allow n to approach the discontinuity from one side. So this is a one-sided limit. Now, because of that, our limit rules sort of kick into play here, and we have some notation for this. This is the limit as n approaches 1 from, and since we're to the left of 1, it would be from the left. So this is the appropriate notation. If it was from the right, then we would use a positive sign instead. Alright, so let's see if we can break this problem down. So we have the integral from 0 to 1 of 1 over 1 minus x dx, and this is going to be equal to the limit as n approaches 1 from the left, the integral from 0 to n, and basically you think of it as n being some value in here that goes up to the value 1. And so just like on the type 1 integrals, our first step should always be to do the integration. So the integration step here is not too bad. We gotta watch out for a little bit of chain rule though, or sort of reversing chain rule, because this is a negative x. Chain rule would multiply by -1, so we're going to have to divide by a -1. But doing that, the integral of 1 over 1 minus x is the natural log of the absolute value of 1 minus x with that negative coming into play. And we're going to evaluate that from 0 to n. So we do the integration step first. Let's go ahead and evaluate everything. So evaluating at the top endpoint, we get natural log of 1 minus n. And evaluating at the bottom endpoint, we get minus a negative, so it'd be a positive natural log of just 1. So I can drop the absolute value there if I need to. And so natural log of 1 is 0. And now we need to take the limit. The limit, the inner part here, this inside part is going to 0. Because if I let n approach 1, then 1 minus 1 is going to be approaching 0. So in the limit, what we're looking at is the natural log of 0 from the right. Now I have to explain this. You got to be very careful about this. So it should be minus natural log of 0 from the right. If n is approaching 1 from the left, then these are values like 1 minus a half, 1 minus 3/4, 1 minus 7/8. We're getting closer to 1. All those values are positive, which means, yes, we're approaching 0, but we're doing it from the right because these are positive values. So the question is, what is the limit of the natural log function as we approach 0 from the right? Well, if you graph the natural log function, so if I look at a graph of natural log, then from the right, it's going down like this. So this is the graph of the natural log of x. And so the limit as x goes to 0 from the right of natural log is negative infinity. So this is minus negative infinity or positive infinity. So positive infinity is not an answer. It's saying that this area, as we move closer to the asymptote, this area blows up. It grows too rapidly to count. And because of that, the actual integral is said to diverge. So we don't actually get a value, we get what's called divergence. And so the integral from 0 to 1 of 1 over 1 minus x dx has an infinite limit, it has an infinite discontinuity, and the two together make this thing diverge. Alright, we're going to take a look at another type 2 integral in the next video, one that's a little bit more difficult than this one, just so we make sure that we understand the type 2 integrals really well. Students typically don't have much trouble with the type 1 integrals, but the type 2s can throw them for a loop a little bit. So we're going to take a look at that and how to split the interval next time. Alright, thank you for watching.